Assalamualaikum warahmatullahi wabarakatuh. A very good morning to all the panels and all the judges. My name is Nurul Wani binti Ibrahim, and today I will present my research entitled Synergistic Step to Remove Leak from Wastewater. So these are the list of the inventor. So start with me. So this is me, Nurul Wani binti Ibrahim. And then the second one is Dr. Siti Nazrah, and then Dr. Nur Aini Zainul, Associate Professor Dr. Subas, and Dr. Muhammad Nur Aiman. So for the introduction, I will start with I will discuss about leak toxicity, effect of leak on human health, conventional metal, and liquid extraction process. So leak toxicity, as we all know that lead is one of the top heavy metal. They are very toxic. They often encountered in industrial wastewater. So it can be absorbed and accumulated in human body and cause serious side effect, and even it can cause death. So for adult, once they are exposed to lead and absorbed, once the lead got absorbed into the body, it can cause kidney damage and high blood pressure. And for pregnant women, it can cause miscarriage, low birth weight, and premature birth. And for children, it can cause intellectual disability and lower IQ. So the effect of leak on human health. So basically, this is how leak. So basically, this how lead get into our body. So one is lead is released from the industry. It will accumulate in our food chain, and it can be absorbed and accumulated into our body through acceleration and inhalation process. And then once it's got once it's leak entering our body, it can cause a serious side effect like respiratory effect, reproductive effect, neurological effect, cancers, and also death. So these are the some of the conventional method that are people commonly used before. The most popular one is the absorption, and then chemical precipitation, ion exchange, membrane filtration, electrolysis, coagulation, and flocculation. However, this conventional method only focus on the removal and detection of leak, but less encountered on recovery of leak. And then this conventional method have several disadvantages like incomplete removal of leak, high energy requirement, production of toxic sludge. So here we can see that some advantages and disadvantages of the conventional method. For example, the absorption method, it produces a large amount of waste product, because we know that in the absorption process, people use agricultural waste product and or industrial waste, so as the absorbent. So that will increase the production of this product. And then for chemical precipitation, excessive sludge production, electrolysis, high operational cost, coagulation and flocculation, sludge production, ion exchange, it cannot handle some concentrated metal solution metric. For membrane filtration, again high operational cost, and bioabsorption and saturation of active site. So in this research, I use liquid extraction process, which is a very rapid, effective, simple, inexpensive, and selective technique. And this LLE process is widely used for separation and purification and removal of targeted metal ion. And liquid LLE process require low viscosity, low cost of chemical, and give a shorter separation time. And then in this LLE process, extractants play an important role in order to extract leak from the wastewater. So these are the three main components of LLE, which are extracted. They are extractant that we use that will extract the lead. NCP agent that function as to recover lead, and that one is a mixture of liquid in which extractant may be dissolved to form the solvent. So this is the process flow. Start with the extraction and sieving process of lead using LNE, and then there are several parameters that we study in this research. Which is concentration of extractant. So 3 different concentration was used, which are 0.005 molar, 0.05 molar, and 0.5 molar of DEPA. And then concentration of synergistic agent. The synergistic agent that was used in this research is sulfuric acid. So there are 3 different concentration of sulfuric acid. Which 0.25, 0.5, and 1 molar of sulfuric acid. And 2 type of diluent, corrosin and toluene. For the steering time, we use 3 different time with 5 minutes, 30 minutes, and 60 minutes. So the variable that keep constant in this research is the treat ratio. So the treat ratio we use is 1:1, means that treat ratio of organic phase to the aqueous phase, and then the stirring speed we use 250 rpm. So after that, the removal and recovery of aqueous solution will be analyzed using atomic absorption spectroscopy. So these are the extraction process. So the extraction process using the LNE technique. So the equal volume of aqueous dissolution and DEPA were mixed together, and then the sample was shaked using a mechanical shaker at 250 rpm, and then the mixture was carefully poured into the separating funnel, and around 50 to 30 minutes the aqueous phase was carefully separated from the organic phase. So the upper layer is the organic phase, and the bottom layer is the aqueous phase. So the aqueous phase, the concentration of lead in the aqueous phase was taken out, and then we will analyze using the AAS. So these are the sweeping process. So for this sweeping process, we use sweeping agent, which is sulfuric acid. So the sulfuric acid and the lead loaded organic phase from the extraction process before were mixed, and then the sample was shaped using a mechanical shaker at 250 rpm, and then the mixture was carefully poured into the separating funnel, and after 50 to 30 minutes the aqueous phase was carefully separated from the organic, and then the concentration of lead strip in the aqueous phase was measured using the AAS. So these are the atomic absorption spectroscopy, the instrument that I use. So in order to analyze the concentration of lead, first we have to do the calibration curve. So we got the calibration curve of lead R squared is 0.9963, which is very good. So for the result, effect of DEPA concentration for the lead removal. So there are 3 different concentrations that we use. There is 0.05, 0.05, and 0.5 molar. So we can see clearly that in the graph that at 0.5 molar DEPA, the percent of lead extract was 96.65%. So we can conclude that more extractant compound exists in the liquid membrane phase, the more lead was extracted. So this is the structure of DEPA in the mid form. So DEPA was able to remove lead ion from the aqueous phase as an acidic extractant by enabling a cation exchange between the lead ion and the hydrogen ion generated by DEPA in the organic phase. So these are the extraction reaction of the lead ion. So effect of sweeping agent concentration. So we can see that in the graph at 0.5 molar sulfuric acid, the percent of lead slip was the highest, which is 82.02%. And the amount of lead slip was increasing as the acidity of the slipping phase increased from 0.25 to 0.5 molar of sulfuric acid. But then, as the acid concentration increased to 1 molar, the amount of lead slip decreased to 48.46%. So it is maybe due to the precipitation phenomenon. So we can see that sulfuric acid is the strong acid. So strong acid can easily strip out the lead from the organic phase. So effect of strain time. So we use 3 different strain time: 5 minutes, 30 minutes, and 60 minutes. The percentage of extraction and slipping of lead was increasing as the strain time increased from 5 minutes to 60 minutes. So a long contact time of the organic phase with the aqueous phase increased the mass transfer between the metal complex, thus increasing the performance for both the extraction and slipping process of PB. So we can see for the PB extraction and PB slipping, we can see that the percentage of extraction and the percentage of slipping was increased as the time increased from 5 to 60 minutes. So effect of diluents. There are 2 types of diluent that are used, which are toluene and corrosive. So we can see that using corrosive as diluent, corrosive is the indicated by the orange bar, and the toluene indicated by the blue bar. So the corrosive as diluent help in the good performance of extraction and slipping of lead at varying concentration of the bar. So this may be due to the physical properties of corrosive, which is has low dielectric constant, means that it's less polar solvent. And furthermore, corrosive as aliphatic are often chosen over aromatic due to their lower water solubility. So we can see in the table, the dielectric constant for the corrosive is much lower compared to the toluene. So for the potential application and commercialization helps to prevent the exposure to human and aquatic life, help to remove and recover lead contamination from the industry, provide rapid and simple technique for lead removal from the industrial effluent, and LLE solvent extraction method can be applied for large-scale industry for heavy metal removal. So as for the conclusion, DEPA shows a good performance in the extraction and slipping of lead at 0.5 DEPA concentration, 0.5 molar sulfuric acid concentration, 60 minutes strain time, and corrosive as diluent. So at 0.5 molar DEPA, 96.65% of lead was extracted, and at 0.5 molar sulfuric acid, 82.02% of lead was stripped. So it means that by using the LLE technique, we can remove and recover PB at high percentage. So it shows that DEPA was a good performance, and this technique is very efficient. So and then only small amount of DEPA was sufficient to remove lead. This technique is very low cost and environmentally friendly. And then we can conclude that LLE process is a very simple, rapid and effective solvent extraction method for lead removal and recovery. And this is my presentation for EREKA. My list of the achievement, my 2 papers still under review. And that's all from me. Thank you very much.